Hey everybody, welcome back to the YouTube channel. Today is going to be vlog day number 7, and we're going to go over a little structure change with the application. Have our data normalizer. Then we have our Firebase. This isn't the best illustration, but we have our Firebase here. And then we have our linear regression model. Now, we're using our Firebase as a way to communicate with the linear regression model because our detailed data is stored on a SQLite. I'm going to put SQL right there for SQLite database local to the microservice. And then additionally, we have another service running called Flask API. So let's switch colors real quick. So we have the data normalizer, the Firebase, and then we have the linear regression model. So the way that these two communicate is through the Firebase. So once the data normalizer is done normalizing all the data, it's going to send a flag to the Firebase. And it's going to look like this. It's going to have player ID. It's going to have a timestamp. And then it's also going to have a Boolean value. I think it's called ready to pool. This is a Boolean value. Data reaches it to the Firebase. The linear regression model has a listener. It's then going to read, hey, this player is ready. So it's going to take that data, going to reach out to the Flask API. The Flask API is then going to reach out to the local SQLite database. It's then going to return that data normalized historical data via the Flask API all the way back to the linear regression model. Now, the purpose behind doing this, instead of storing everything to the Firebase, initially I wanted to save my reads and writes and kind of limit how much time I'm hitting the Firebase for information. And if I stored the individual player data, I would have to read every last individual's player data. Also, we're going to be using a lot of storage on the Firebase database. I want to say that Firebase gives you 50,000 writes each day, and I could see this exceeding 50,000 writes and reads a day. So given all the other stuff that I'm doing, like user interaction, a lot of other stuff, right? So I kind of wanted to take this process out of the Firebase and make it a little quicker and then save me some money. But then I started to think, am I really saving money though? Because at the end of the day, I'm still reading and writing this value here. Right now, Firebase is acting as a communication method in between the data normalizer and the linear regression model. So I thought to myself, there has to be something else that we can use that's free and a better way that we communicate with the data normalizer and the linear regression model, right? So we're going to go ahead and erase this. So as I'm thinking, I'm kind of running scenarios with ChatGPT. And what we came up with is using another microservice called Redis Stream. It'll subscribe to the Redis stream called player flags. And anytime the data normalizer writes to the Redis stream, it will then send a message to the linear regression model. And then from there, it'll do the rest of the process, asking the Flask API for information. Flask API reaches out to the SQLite database, and then it's going to return that information back to the linear regression model. Now, why is this better? One, I can deploy a Redis stream on Oracle Cloud free tier and it'll remain free because it's always free subscription. Now, one thing I started to think of is latency. So with any system, you're going to introduce latency. So how can I make this thing as quick as possible, reducing the latency on this? So what I started to think is since Data Normalizer and Redis Stream, they both live on Oracle Cloud Free Network. However, these two microservices, they're on two different accounts. So what I first thought of is using a virtual cloud network and not going over HTTPS for the internet and just serving it locally. Only problem with that is, again, we have two different accounts. So I haven't done enough research to see if there's an ability to communicate between microservices using two different accounts. So that's another thing that I have to research. But as of right now, we're going to set it up as Redis Stream. We're going to serve this over HTTPS. And yeah, that's how the data normalizer will now talk to the linear regression model. And we're going to do this completely free. So with the Redis stream, we have a few things that are pros and cons. We're just going to list that out here. So the first pro will be message persistence. So message persistence. Right? So what this means, we're going to have a reliable connection in between the Redis stream and the linear regression model. Say something, for instance, disconnects in the middle of a message getting transmitted. Once they reconnect, the Redis stream is going to ensure that that receiving microservice will still get that message. The next thing that'll be a good pro for us is that it is free infrastructure. With Oracle Cloud free tier. With Oracle Cloud free tier, I can push as much data as I want through this Redis stream, and there's really no caps. There's really nothing that I got to worry about as far as billing goes, because like it said in the title, it's Oracle Cloud always free tier. So it'll remain free up until I need to request more resources. Another thing with the Redis is going to have lower latency. So compared to Firebase, the Redis stream is going to have lower latency just because Redis in nature is way faster. It uses RAM versus disk. So a lot of the stuff that we're going to get is going to be really, really responsive. A con that we have is that with Oracle Cloud free tier comes some limitations. So with this, we have a 6 gigabyte cap. So if you didn't know, Redis, they use in-store memory, which means whatever we have available for the RAM is what we have to use to serve these messages. Now, I don't foresee this being a problem because as we're going to clear the memory as we don't need the stuff in the store anyway. So I don't foresee this being a problem, but it is a thing of note, I would say. I think the last thing will be the challenge between connecting these two if we try to do it locally. So with that being said, if we would do the VCN route, we either have to create some type of bridge using a VPN tunnel maybe, or possibly figuring out how we can get the two accounts to connect through Oracle. So I'm gonna write that down as network challenge. So given this structure, yes, we are moving to a virtually free, if not free, structure between communication with these microservices, right? Now, if for some reason we can't get the VCN up or that bridge going, then we can go ahead and revert back to the Redis stream. With this setup, using Redis stream, we'll be able to have a free means of communication between these microservices. I even thought about possibly creating a VPN tunnel between linear regression model and the data normalizer. That way they can communicate directly. And it seems as I would have to run something that can ensure that the message got delivered anyway, because if that connection breaks, what's there to say that that message actually got through? So I think Redis Stream is going to be a good free option. And yeah. So if you have any questions about anything we talked about today, leave a comment down below. And if you want to see me code out these new features in future videos, just leave a like because it helps the channel grow. Peace.